Hello everyone, myself Gurinder Pal Singh. In this video, we will start with our chapter Alcohol, Phenol and Ether. Students, in this chapter, we will study about nomenclature, methods of preparation, physical and chemical properties, and uses of alcohols, phenols and ethers. This is not the end here. Along with all these things, we will study about identification of primary, secondary and tertiary alcohols, mechanisms and electrophilic substitution reactions of phenols and acidic nature of phenol. In the last unit, we have discussed the chemistry of the family of haloalkanes and haloarenes. Alcohols and phenols are formed by replacing one or more hydrogen atoms in hydrocarbons by OH groups. Students, in case of alcohols, the OH group is known as hydroxyl group, while it is called phenolic group when attached to benzene ring. Since they have common functional group, most of the characteristics of alcohols and phenols are expected to be same. Students, most of the characteristics, not all the characteristics. Students, if I talk about ethers, then ethers are the organic compounds in which two alkyl or aryl groups are attached to a divalent oxygen. The general formula of ethers is ROR, where R may be alkyl or aryl group. Students, alcohol occur widely in nature and have many industrial and pharmaceutical applications. Some of these have many important applications in day-to-day life. For example, ethanol, simply called alcohol, is widely used as an important component of alcohol beverages, as an antiseptic in the form of rectified spirit, as a solvent for many medicines, liquids and varnishes. Methanol is toxic to humans but is industrially used as a solvent and as a starting material for many important compounds such as methanol, ethanoic acid and gasoline additives. Students, do you know the sugar we eat, the cotton used for fabrics, the paper we use for writing and for manufacturing books, notebooks, newspaper, etc. are all made up of compounds containing OH groups. Simple phenol is an antiseptic and disinfectant. A phenolic compound, hexachlorophene, is a constituent of several mouthwashes, deodorant soaps and medicinal skin cleansers. Well students, phenols are also used for the manufacture of dyes, resins, etc. Now, if I talk about ethers, then diethyl ether has been extensively used as an industrial solvent. A number of naturally occurring phenols and ethers are used as flavoring and in perfumes because of their very pleasant odor. Now students, if I'll talk about the classification of alcohols, then alcohols have been classified as mono, di, tri or polyhydric compounds depending upon the number of hydroxyl groups present. Monohydric alcohols may be classified on the basis of hybridization of the carbon atom to which the hydroxyl group OH is attached. Students, in this type of alcohols, the hydroxyl group OH is attached to an sp3 hybridized carbon atom of an alkyl group. They are further classified as primary alcohols, secondary alcohols and tertiary alcohols. Now students, look carefully. In primary alcohols, which have one or none alkyl group on the carbon bonded to OH group, example is ethanol. In the similar manner, if there are two alkyl groups on the carbon bonded to OH group, it is called secondary alcohol, for example propane 2-ol. And students, tertiary alcohols have three alkyl groups on the carbon bonded to OH group. An example is 2-methylpropane 2-ol. In allylic alcohols, the hydroxyl group is attached to a sp3 hybridized carbon next to a carbon-carbon double bond, known as allylic carbon. These alcohols can also be classified as primary, secondary or tertiary allylic alcohols. Students, in benzylic alcohols, the hydroxyl group OH is attached to a sp3 hybridized carbon atom next to an aromatic ring. These alcohols may also be classified as primary, secondary and tertiary benzylic alcohols. These are also called aromatic alcohols. In this type of alcohols, the hydroxyl group is attached to a carbon-carbon double bond. These are of two types, vinylic alcohols, phenols. In vinylic alcohols, they contain OH group attached to a carbon atom of a carbon-carbon double bond. Whereas in phenols, OH group is attached to a carbon atom of benzene ring. Students, if I talk about the classification of ethers, then ethers are like simple or symmetrical ethers, mixed or unsymmetrical ethers, aliphatic ethers, aromatic ethers, cyclic ethers. In simple or symmetrical ethers, both the groups, whether alkyl or aryl group, are the same. For example, dimethyl ether, diethyl ether, diphenyl ether. In mixed or unsymmetrical ethers, they are not the same, like ethyl methyl ether and methyl phenyl ether. Students, ethers are classified as aliphatic ethers if both the groups are alkyl groups. For example, dimethyl ether, diethyl ether, and ethyl methyl ether. Now, in aromatic ethers, at least one or both the groups attached to the divalent oxygen are phenyl or aryl groups. For example, diphenyl ether, methyl phenyl ether, phenyl benzyl ether. And students, in cyclic ethers, oxygen atom is a part of the ring. For example, ethylene oxide. Now, let's start with the nomenclature of alcohols. First, we will do the nomenclature of monohydric alcohol. Students, according to the common system of nomenclature, alcohols are named as alkyl alcohols. In this structure, methyl group is attached to OH group. So its common name can be methyl alcohol. In the similar manner, common name of this compound is isopropyl alcohol. And formula of this compound will be tertiary butyl alcohol. But students, according to IUPAC system, alcohols are named by replacing the last word E of the corresponding alkane by ol. For branch chain molecules, the longest chain containing the functional group is selected and is regarded as the parent chain. So this is the parent chain. And the numbering is done in such a manner that the functional group may get the lowest number. So we will start numbering from right to left. At number 2, methyl is present, so the formula of compound is 2-methylpropane 1-ol. 1 because OH group is attached to carbon at number 1. So by applying the fundamental rules of IUPAC name, I will do the numbering from right to left. So the formula of compound will be prop 2-ine 1-ol. In this structure there are two OH groups. So we will apply the rule of set of locants. According to the lower set of locants, we will do the numbering from right to left. So the formula of compound will be butane 1,3-diol. Students, cyclic alcohols are named by using the prefix cyclo and considering the OH group attached to carbon 1. So students, IUPAC name of this compound is cyclohexanol. Polyhydric alcohols contain 2 or more OH groups in their molecules. The dihydric alcohols means containing 2 OH groups are also called glycols. So the formula of this compound will be ethylene glycol. This is the common name. But students, in IUPAC system, the formula will be ethane 1,2-diol. Now we will study the nomenclature of phenols. Well, according to the common system of nomenclature, the parent member of the family is phenol. The other members are named as derivatives of phenols. The position of the substituents is indicated by the prefix ortho for 1,2, meta for 1,3, and para for 1,4. So students, common name of this structure is meta-methylphenol and IUPAC name is 3-methylphenol. As we know that 1,3 position is for meta and methyl group is present at carbon 3 of the benzene ring. Students, according to common system, ethers are named according to alkyl group attached to the oxygen atom. The names of two alkyl or aryl groups linked to oxygen are written as separate words alphabetically followed by word ether. But students, According to IUPAC system, ethers are named as alkoxyalkanes. The larger alkyl group forms the parent chain, while lower alkyl group is taken with the ethereal oxygen and forms a part of alkoxy group. So students, common name of this compound is dimethyl ether and IUPAC name is methoxy methane. And the common name of this compound is ethyl methyl ether and IUPAC name is methoxy ethane. In the similar manner, common name of this compound is methyl phenyl ether and IUPAC name is methoxy benzene. Next, we will study about isomerism in alcohols and ethers. So students, isomerism is a phenomenon in which more than one compound have the same chemical formula but different chemical structures. In chain isomerism, if I'll talk about alcohols, then in this, isomers differ in the chain of carbon atom attached to the hydroxyl group. This is the example of chain isomerism in alcohols. In this, isomers differ in chain of carbon atoms attached to the hydroxyl group. Now, if I'll talk about chain isomerism in ethers, then these have same alkyl groups on either side of the oxygen atom, but different arrangement of the carbon chain within the alkyl group or groups. This is the example of chain isomerism in ethers. So students, look carefully in these examples. They have same alkyl group on either side of oxygen atom, but different arrangement of carbon chain within the alkyl group or groups. Now, if I talk about functional isomerism in alcohols, then monohydric alcohols containing two or more carbon atoms exhibit functional isomerism, in which the isomers differ in the functional group. This is the example of functional isomerism in alcohols. Students, if you look carefully, then you will find that isomers differ in the functional group. Students, if I talk about functional isomerism in ethers, then ethers containing two or more carbon atoms are functional isomers of alcohols. This is the example of functional isomerism in ethers. If we observe carefully, then we will find that ethers containing two or more carbon atoms are functional isomers of alcohols. Now students, if I talk about stereoisomerism or optical isomerism, then the members of the family with a chiral carbon atom also show optical isomerism in their molecules. This is the example of optical isomerism in which butane 2-ol exists as two enantiomers, which is represented by the Fischer formula. Now, if I talk about metamerism in ethers, then ethers have same molecular formula but different alkyl groups on the either side of the oxygen atoms. This is the example of metamerism in ethers. Students, if we will analyze carefully, then we will find that these ethers have same molecular formula but different alkyl groups on either side of the oxygen atoms. This is all about isomerism in alcohols and ethers. Hope you like this video. Thank you so much, students.